Hey guys, welcome to this video on solids of revolution. So this is a skill that we're starting to develop in our methods folio and that we're going to really concentrate on here. So firstly, we've got what we've seen in our methods folio is rotating a function around the x-axis. Where we're going to extend it a bit here is when we rotate a function around the y-axis. So we're going to get straight into those, and then we're going to have a region composed of two functions that we then rotate around the x or the y-axis. So let's get straight into our first example. We have find the volume that's obtained when this function is rotated around the x-axis from 0 to 3. So straight away, the formula for this is going to be the integral from 0 to 3 of pi multiplied by our function squared. Now this is our function, 3x squared plus 2, and we're squaring that. Okay, so you can put that straight in your calculator, and that's going to be the answer that obtains, all right? It's the integral from a to b of pi times the function squared. Now let's process this one a bit, because there's a couple of tricks we need to watch out for. Now that pi can come straight out the front, and the first thing we absolutely need to do before we integrate is fully expand this. So I'm going to use a perfect square expansion to simplify that. It's going to become 9x to the 4, plus then we're going to have 2 times 3x squared times 2. So that's going to be 12x squared, and then plus 4 with regards to x. All right, and now we're ready. We're in a state ready for it to integrate. So the pi is going to hang out there, and we're going to have 9x to the 5 on 5, plus 12x to the 3 on 3, plus 4x from 0 to 3. Pi still hanging out the front there, and now we'll perform the substitution. 9 times 3 to the 5 on 5, plus now 12 on 3 is 4, so that can simplify. 4, 3 to the 3, plus 4 times 3, and then let's put a bracket there. We've got to take away, now when we sub 0 in, all of them have an x, so all of those are going to 0. And so then what we're left with is pi multiplied by this. And remember I've said don't try and put this long stuff in your calculator. Let's just jump straight to that, and we know we're going to generate the right solution. So I did it before. I got 2,787 on 5 lots of pi, or as a decimal, 1,751. So we'll go 1750 units cubed. Excellent. So let's move on to our next example. Find the volume of the solid formed when the area bound by this relation, x squared plus y equals 7, over the interval 1 to 7 is rotated around the x-axis. So there's a couple of things we have to do here first. And it is helpful for us to graph it, right, to understand what it looks like a bit. Now this function, all right, they've been a little bit deceptive here with the notes. This function can be simply rearranged to y equals 7 take x squared, right? And what that tells you, like this is a quadratic, all right, and it's opening downwards, and it has a y-intercept of 7. All right, so you already know, so that'll be down here, sorry, that number up there is 7, here's the x-axis, and it looks, that's the shape that it's going to have. Now we're performing the integral from x is 1 to x is 7. Now when we're rotating around the y-axis though, there's a couple of things we have to watch out for. Notice how we're integrating from c to d. Now those are the y coordinates, all right? Those are the y coordinates over a specific interval, and we have x squared, which is a function of x, all right? So there's two things we have to do. What we need to do is, we've got the domain here over which we're finding it rotated in terms of x. We need to find the corresponding y values for that. So we need to say when x is 1, what's the value of y? And when x is 7, what's the value of y? So let's go ahead and do that first. When x is 1, we're going to have y equals 7 take 1, which is 6. And we're going to have when x is 7, y is going to be 7 take 7 squared. So that's 7 take 49. We're going to have minus 42. So we've got the two values of y over which we're going to perform this integral. So we've got y. The other thing we need to do is express it as a function of x. Now up here, we expressed it as a function of y, and the reason we did that is because we know how to graph that, okay? So that was just to visualize it a little bit. If we want to express this as a function of x, what we need to do is we need to isolate x all by itself. So if we have x squared plus y equals 7, we're going to express it as x squared equals 7 take away y, and then we're going to get x is plus or minus the square root of 7 take y. Okay, so that's going to be the function, and we'll just consider the positive component because we only need to rotate one of those parts around the y-axis. So we have a function of x, and we have a boundary in terms of y. We've got all of the requisite components we need for the integral statement. So what are we doing? We're doing the integral from the lower y boundary, minus 42, to the upper y boundary, positive 6. All right, so we're not using the x values, we're using the y values. Why? Because we're rotating around the y-axis. And here we have our function of x. All right, so this is the formula we're using, right? So we need to go our lower y boundary, our upper y boundary, pi, and then our function of x, which is the square root of 7 take y, and then that's squared, and of course we're integrating with respect to y. All right, so let's just simplify this a little bit before we perform it. Pi can come out the front. Now, square root squared, that's going to cancel, isn't it? So what have we got here? The integral of 7 take y with regards to y. Okay, we can go ahead and crunch that. That's going to be 7y take y squared on 2 from minus 42 to 6. And we'll process that one a little bit. So we're going to have 7 times 6, take 6 squared on 2. Pi out the front here. And then we have take away 7 times minus 42, take away minus 42 squared on 2. Close the bracket there and close the big bracket there. All right, and now when we evaluate that one, I've done that just before again, saves a bit of time. We've got 2,401 on 2 pi, and so we've got 3,771. So again, to 3 significant figures, 3770 units cubed. All right, and then we'll move on to question 3. So we have find the volume that obtains when the area bound by x is 1 and these functions is rotated around the x-axis. So if we look at the graph, right, I've shown the area that's where we've got there. That's the area. Here's the function 1 on x. Here is the function x squared on x on 4 squared. And x on 4 squared, like what I've done is I've simplified that straight away to x squared on 16. All right, and so what we're doing is we're finding that area and rotating that around the x-axis. So the way that's going to be done, the first thing we need to do is find that point of intersection, right? We need to know when do these two functions meet one another. So that's what my top line is, x squared on 16 equals 1 on x. Okay, cross multiply and then cube root. So that means our upper boundary of our integral is going to be the cube root of 16, and our lower boundary we're told is 1. We want the area bound by x is 1 and the functions. Okay, so it's almost like a triangle, right? Now, the formula we're going to be using is this one here. All right, it's the integral from a to b of pi times the first function squared, take the second function squared. So that's what we've got here. We've got the integral from the lower boundary to the upper boundary of pi times the first function squared, take the second function squared. All right, again, one we can mash in the calculator. Let's go through, let's punch it out here using the fundamental theorem of calculus. So the first thing we're going to do is square everything, and then we can integrate it. Pull the pi out the front. So we're going to go from 1 to the cubed root of 16. We're going to have x to the minus 2. And then over here, we're going to have x to the 4 on 16 squared. Just do that really quickly in my head. 256. And with regards to x, all right, so we've got all of the components and now we're ready to integrate it. Pi is hanging out there. Integral of x to the minus 2 is going to be x to the minus 1 on minus 1. And integral of x to the 4 is going to be x to the 5 on top of 5. And 5 times 256 is 1280, I reckon. All right, and we're going from 1 to the cube root of 16, which means the area then is going to be the cube root of 16 to the power of minus 1, or it can go to the bottom of the fraction. That's negative. Take the cube root of 16 to the power of 5 on top of 1280, and then take away we're going to have 1. Actually, that's going to be -1, isn't it? Because it's 1 on top of -1. And then we have take away again, 1 on top of 1280. All right, and that's a pretty nasty one, but we'll smash that in the calculator. And I've got squared need a few more brackets. Uh, 1.65. 1.647, so we'll go for 1.65 units cubed. All right, so a little bit involved in those ones. Yeah, good luck. Let's see how we go with it.